So, you want to save the world with clean energy? Make money doing it? Confused about the economic and technical realities of residential and commercial solar, batteries, heat pumps, EVs? Want the real-world scoop on new energy technologies, not manufacturer hype? Then tune in to the Weekly Energy Show, hosted by Barry Cinnamon. Insights from Barry's 40-plus years in the solar and energy industry will help you understand the future ways we'll generate and consume energy. And now, here's Barry.
Welcome to this week's Energy Show. Now, solar's the fastest growing source of new energy in the United States. And batteries are becoming ubiquitous, both for utility use and for home use. And these home batteries are not only for backup power, but they also allow you to time shift your energy use to reduce your electric bill. It starts to make a really big difference because of the big difference between peak rates in the evening and off-peak rates pretty much every other time. So with solar and a battery, you can save money and keep your lights on in the next blackout. But when you search for solar or a battery on your phone or your computer, you're going to get deluged with companies offered what I call too good to be true prices and features and deals. It's hard to separate fact from fiction. So on this week's show, we're going to dive into many of the questions that I suggest you ask when considering solar and storage. This is really an educational podcast about learning about the details of solar and storage, so you won't get easily scammed, and then you'll really understand how to design the best system for you, instead of the system that's going to make the most sense for the pushy solar salesperson or the company that's doing the installation. So we're going to start with relatively simple solar questions, and then we're going to dive into some of the details on batteries. All right, first question. What happens if there's shading on my roof? Basically, what happens is if there's no direct sun on the solar panel, you're going to get very, very little generation. So if there's shading, even though you can see the solar panels, it may be a little bit bright, very, very low output. And that means basically solar panels that are under a tree or solar panels that are on a roof that's shaded by another part of your house are really not going to generate much power at all. The industry's changed a little bit, and now we do get some pretty good generation from solar panels on the north side of the roof where the sun isn't usually as strong compared to the south, but they still work. But I cringe when I see solar panels installed on north-facing roofs shaded by a pine tree. Those panels are going to perform very, very poorly. Now, if the system is slightly shaded, you're still going to get output. So what happens a lot of times is a shadow from a tree or part of the house may go over the solar panels during the day. That's not so bad. You'll lose a proportional amount of output, but it's not going to be that bad. Now, keep in mind that the shading isn't linear to the amount of shade. So if the panels are 10% shaded, you actually may lose more than 10% of the output for two reasons. One, the solar panels themselves have cells that are wired in ways that if you shade 5 cells, you may lose the output of the whole panel. And then also when you have a string of solar panels, if a few panels in the string are completely shaded, that may knock out the output of the whole solar string. There are ways to compensate for that, and we'll talk about that more later. All right. Next question, and this is kind of a basic one, and it's a little bit of an electrical education to understand, but here it is. Does my solar system work during a blackout? Well, the simple but surprising answer is no. And the reason is that all solar inverters are designed to automatically shut off if there's no utility power. Now, this is a feature that's there to protect utility workers, because imagine if there was a wire down on your street and you had solar, but your inverter was still working, it would still be sending power back to your house and then back to the electric grid, and that's dangerous. So every system with an inverter automatically shuts down if there's no sun. Now, there is a way to run your solar system if there's a blackout or if the power's off, and that's if you have a battery and an automatic transfer switch. And that transfer switch isolates your house from the grid. You're kind of like on your own little island, and then the inverter and the battery work together so they can partially or fully power your house. And this is one of the real reasons why so many people are putting in battery systems, because they get backup power even when there's a blackout. All right, next question. How can I expand my existing solar system? Well, this is something that's really come up a lot over the past 25 years or so that I've been doing installations, especially over the last 7 or 8 years here in California and around the country, because people are electrifying their life cycles. They're buying electric vehicles, they're putting in heat pumps, they're putting in induction cooktops, and all of these things require more energy. So a solar system that was sized maybe 15 years ago that was good just for the basic house usage, now if people have an EV and they put in a heat pump and maybe it's hotter and you need to use the air conditioner more, you need more solar. So it's a good question. How do I expand the system? Well, basically, if you have enough extra sunny roof space, you can always add more solar panels. Also, if you put in a system 15 or 20 years ago, you may have had a low efficiency solar system. Those solar panels aren't working as efficiently now. And also, new solar panels are 22% efficient, whereas the ones that I started putting in back in 2001, they were only 12 or 13% efficient. So if you want to expand, if you have sunny roof space, you can do it, but it's very important. It's tricky to add new panels to an existing system. It's very likely that if you put in, let's say, another 10 panels, you're going to need a new inverter because your existing inverter can't support those solar panels. Some people may have microinverters, and theoretically, it's easier to add more panels to the microinverters because you don't need to buy a new inverter. But the problem is that a lot of these microinverter systems that are sold now in 2024 are not compatible with the ones that you might have put in 2015 or any time earlier. It's tricky. So here's our advice, and this is just from doing this forever and looking at things from an economic standpoint. And I apologize if it sounds a little bit self-centered, but you're going to get the same answer from experienced solar installers. If your existing panels in your existing system is more than 10 or 15 years old, seriously consider replacing your old panels. Mixing new panels with old panels really creates compatibility issues. It rarely works well. So inevitably, those old panels aren't as efficient and they're going to need to get replaced sooner. And, if, let's say you had a 5 kilowatt system put in 2015 or 2010, and then you want to add another 5 kilowatts because you've got an EV and a heat pump, you're going to need a second inverter. Now you got two inverters, one that's 15 years old and one that's brand new. They're going to have different monitoring. They may have from different manufacturers, and it's a little tricky. So you want to kind of take a step back. It's very doable, but work with installers that are experienced there. You also, if you're putting in a new inverter at more capacity, you may need to upgrade your electrical panel or downsize your main breaker or put in something called a power control system. We'll talk about that more later. But there's always ways to do it. You can sometimes add a few more panels. You can sometimes add more, but watch out with the compatibility issues and work with installers that know how to do it. Otherwise, somebody's going to throw a price at you and you're going to sign a contract. And then when the engineering's done or you pull an electrical permit, it's going to turn out, the inspectors aren't going to allow you to make that change. Okay, now, big caveat here. In California, there's a change that went from net metering 2 to net metering 3, and the utilities managed to make it very difficult to expand an existing net metering 1 or net metering 2 system. Basically, they say if you have an older solar system that was installed prior to 2023, you can add 1,000 watts of panels, which is like 2 solar panels, or no more than 10% of the size of the system. If you want to put in a bigger system, they as the utilities require you to go on the new net billing tariff, which generally isn't nearly as good as the old net metering tariff. Now, there's some loopholes that experienced solar installers can help you navigate, and that's why I suggest you talk to an experienced installer. There's other things you can do, like putting in a battery and then adding the new solar panels that they only feed the battery, and there's some ways around it, but you want to work with an experienced installer. Okay. Next question. What assumptions are you making about the orientation and shading for my system? Now, the vast majority of solar installers use software to design the system. And there's assumptions that go into that design. Assumptions about the amount of shading on the roof orientation, your local climate. So it's critical to accurately determine the energy output and savings for your system so you can figure these things out. But these energy output and saving numbers are driven by assumptions. So it's a good idea to ask your solar salesperson about the assumptions that were made in his or her recommendations for you. And you're going to need to accurately know those output numbers because you want to compare quotes for different installers. And we want to do that on an apples and apples basis. One installer may be an old line company, very experienced, very conservative. They're going to basically say you have 15% shading. And you may have another company that's going to come out and say, well, we're going to ignore the shading. We're going to get more output for the system if we ignore the shading. And we're going to kind of goose the output of the system because we're going to assume that everything's on the south roof instead of maybe the east or the west, which is going to be lower. So you got to be careful about that. And I've seen these things happen. Generally, the experienced installers are more conservative, and then companies that are trying to make a fast buck, they can play fast and loose with the assumptions and give you a better deal, and it's not going to turn out to be the case. So just be careful. Okay. So we talked a little bit about basic solar. Now let's dive into battery systems. It gets a little bit more complicated. So quick discussion of the key specs for solar and battery systems. So for basic solar, in order to size the system, we talk about systems that are in terms of watts or kilowatts. Really simple. It's kind of like the measurement of the horsepower of your car. If you multiply the number of solar panels that you're looking at putting on by the power output of each panel. So for example, if you're getting quotes for 20 solar panels, each with a solar power output of 400 watts, that's an 8,000 watt system. And so when you compare quotes, try to get quotes that are all for about the same number of panels in the same location. Then you're going to be comparing on an apples and apples basis instead of, one installer may say, I want to put them all on the south roof. They won't fit. Another installer is going to say, we've got to use the east and the west roofs because there's less shading and it's going to be more efficient. You're going to kind of get a mix. So get everything kind of that correlates together. Okay, now, solar systems are pretty simple. Battery systems are more complicated because you have to take into account the power output of the battery, which is measured in kilowatts, the energy capacity of the battery, which is measured in kilowatt hours. It's the number of kilowatts times the number of hours. That's energy. And then there's also distinctions between systems that are called AC coupled or DC coupled. So we'll dive into that. Power is measured in watts or kilowatts. A kilowatt is 1,000 watts. And there are two measurements of power. There's continuous output power and peak output power. So what you want to do is you want to add up the wattage of everything that's running at once, and that's going to give you the continuous output power. And the continuous output power of your battery system that's on the specifications has to be greater than the sum of all your active appliances. In addition, the peak output power of the battery, once again, that's going to be on the specs, has to be greater than all of your active appliances and the startup power for all your motors. Usually this is the one that's tricky. You don't have enough battery peak power. Newest systems have a really high peak power output, but some of the older ones don't. All right, so let's go look at an example. Let's say you have LED lights. Each is 5 watts. You have 20 lights. That's a total of 100 watts. Let's say you have other appliances, TV, entertainment system, internet, etc. They're totaling 400 watts. Your fridge is running at 500 watts. Your pool pump is running at 1,500 watts, but every time it starts up, it draws 5,000 peak watts. Your AC running at about 3,000 watts, but when it starts up, it requires 6,000 peak watts. So if your lights and appliances are on, and your fridge is running, and your pool pump tries to start up, and your AC tries to start up, that's a total of 12,000 watts of peak power. If you have an older battery system that has a 5,000 watt continuous power and a 7,500 watt peak power output, so the most power the battery can put out is 7,500 watts, but you're trying to draw 12,000 watts, that battery is not going to start because it's overloaded. And you can see why big appliances with motors like air conditioners and pool pumps easily overload a single battery system because they don't have enough peak power. Now, the next important measurement is energy capacity. That's measured in kilowatt hours. So to find out how long your battery will last, and this is what people are always saying, how long is my battery going to last? Well, the answer, it depends, and we've got to do some analysis. So start with the charge level of the battery. Let's say you have a 10 kilowatt hour battery, but it may not always be charged up to 10. Let's say it's average charging up to 8 kilowatt hours. So it's 80% charged, partially charged. You divide that 8 kilowatt hours charge level of the battery by the continuous power output of all the appliances that you measure in kilowatts, and the result is the number of hours your battery will last during a blackout. So here's an example. Let's say if your lights, your appliances, fridge, pool pump, AC running, you're using a total of 5,500 watts. And let's say you have a 10 kilowatt hour battery, but being very specific here because the batteries aren't always fully charged. Let's say it's charged to 8 kilowatt hours, 80%. The battery's going to last only an hour and a half. And you can see the big appliances like your air conditioner and pool pumps, that drain the battery really fast. And also keep in mind that your battery is not always going to be fully charged. In the reality, in many cases, people are cycling their battery fully from 100% down to like 20 or 30% at night. And if your battery's at 30% at night, or 50% at night. In this example, let's say there was a power failure at midnight and your battery was at 50%. The battery's only going to last for 0.9 hours if you're trying to run these big appliances. Now, if the blackout happens during the day, the solar will be able to operate and keep the battery topped off. But it happens at night, and this is what's more common. People say, hey, my battery kind of ran out of power at 3 in the morning and my CPAP machine stopped working and my wife kicked me off onto the couch. So it's good to kind of talk to your installer and get some ideas of what the reasonable expectations are. The best thing to do is make sure that you have a system that can do some automatic load shedding with smart breakers or smart circuits or a load management panel. And these things can automatically turn the large appliances off, like a pool pump and an air conditioner, if there's a blackout. And that means that you're no longer drawing that big power, and your battery's much more likely to last easily throughout the night or maybe into the next few days if you're not using these really big appliances. Okay, so there's two ways that we describe battery systems: AC coupled battery systems and DC coupled battery systems. What's the difference between AC coupled and DC coupled battery systems? And this is a term that the industry uses to describe the design of your battery system. AC coupled battery systems plug the existing solar inverter directly into the battery system. So you have two inverters, one inverter that you had before for the solar system and one for the battery system. So it's usually with an AC coupled system, somebody says, I want to add a battery to my system. AC coupled systems are generally a pretty good way to go for retrofits. DC coupled battery systems use one inverter. And so you have that one inverter and it takes an input, DC input, from your existing solar system or your new solar system, and it takes the input from the battery. It's a little more elegant, but it's a little more complicated because you generally can't connect an existing solar system to a DC coupled battery system unless it's from the same manufacturer as the battery system, because they want to make sure that the design is the same. And that's a little tricky, but this is one of the questions that your solar installer should really give you a quick answer. Okay, now coming back to the batteries, let's switch to the important questions. Now that we know a little bit about AC coupled and DC coupled, let's switch to the questions that you want to ask your battery salesperson or installer. First question people ask, and we talked about the background of this: how long will my battery system last during the blackout? It depends. It's not a simple answer. So we talked about this. We ran the math before. It depends on how many appliances you're running. It depends on the power requirements of each appliance. It depends on the state of charge of the battery or batteries. And it depends on the ability of your solar system to recharge your battery. And this is kind of tricky because let's say it's a cloudy day. It's daytime, but your solar system normally may put out 5,000 or 6,000 watts, but if it's cloudy, it's only going to put out 1,000 watts. So your solar may not really recharge the battery too much. So the way we kind of look at this is most homes, when they're running the bare essentials, just like the essential loads, your fridge, your lights, your Wi-Fi, little gadgets plugged into the house, the electrical draw in the house may be around 500 watts or 0.5 kilowatts. So if you're just running the essential things, that 10 kilowatt hour battery could run 20 hours if it's only drawing 500 watts. So if there's a blackout at night, and let's say your system was discharged a little bit down to 30%, if there's a blackout at night, you're only drawing 500 watts, the battery's going to last 6 hours. Maybe you're going to get to the morning and the sun's going to come up and it's going to recharge. But the thing is, if you're using a large appliance like an air conditioner and your pool pumps kick on, like I had that situation at my house, that 10 kilowatt hour battery is only going to last a couple of hours if you're using 5,000 watts continuously. So the answer to the question, how long will my battery last? No installer can give you a straight, this is definitely the number of hours, 17.2 hours. It's not going to happen. You really got to do the calculation. Now, another way to roughly determine on average what the battery capacity is to look at your electric bill. Let's say you're using the average number of kilowatt hours in the average house in the U.S., which is 1,000 kilowatt hours a month. It's about 33 kilowatt hours a day. You should get a battery with the capacity of about at least 80% of that 33 kilowatt hours. That's 26 kilowatt hours. That's typically two of the most popular batteries on the market. So one battery will be kind of tricky for you to be confident that you're really going to have enough power. Okay, next question. Can I run my major appliances with my battery? Well, the best batteries on the market from companies like Franklin and Tesla and Enphase and SolarEdge, they can start large appliances because they've got some pretty high peak power output and they can be combined to give you even higher peak power output. So one way of kind of thinking about this is just let's use an analogy. Batteries store energy, kilowatt hours, and have an output power in kilowatts, similar to a car. The car stores energy in the gas tank, and the power of the house is the horsepower. So if you say to yourself, how long can you drive? It depends on the power of the engine, and it depends on how much gas you have. It's kind of the same question that we can kind of interpret to a battery system. How long is the battery going to last? Well, it depends on the gas in the tank, the kilowatt hours of the battery, and it depends on the power that's being used in the house. So generally, just because the large appliances use a lot of power, it's generally better to try to avoid running those large appliances at night. Run them only during the day when you have sun, because the sun's going to be recharging that battery. It becomes a little trickier for people with heat pumps. That's my case. I have a heat pump, and it draws power at night to heat the house in the winter, and I need more battery capacity because I need power at night. Or it's not so bad. I can buy power from the utility. Power is really cheap in the evening, but if I do really want to get through the evening, I need a bigger battery. Okay, so next question that people ask now that they kind of go through this math and they say, I want a battery. I've got a lot of blackouts. Can I add a battery to my existing solar system? The answer is you can almost always add an AC coupled battery to your existing solar system. That's because these battery systems don't really care what was going on with solar. They take the circuit breaker from the existing solar system and they plug it into the battery system gateway or battery system panel, and it's really easy to do. If you want to add a DC coupled battery to your existing solar system, a little bit trickier. The reason is that the inverter for the solar has to be compatible, has to have the ability to handle a battery, and not all the systems can do that. I look at the example of the computer industry and the printer industry. The computer and the printer industry had the same problem, but they fixed it early on. They have these things called device drivers, basically firmware. So almost any computer you buy, a laptop, whatever, desktop, it'll work with almost any printer. We're not at that level of interoperability yet with batteries and inverters. The battery technology is evolving so fast that the older inverters are usually not compatible with new batteries. So if you have an older inverter, you may need to upgrade to a new battery compatible inverter if you want to do DC coupling. If it's AC coupling, it's pretty easy. All right. We talked about the hardware. Let's talk a little bit about service issues. Many states require the solar or battery contractor to provide warranty service. So that's a good question. The question to ask is, how many battery systems has your company installed in my neighborhood? When you want to find a contractor, you want to find out how experienced they are with the new technology. Installing solar is much easier than installing batteries. So it's really important to find a contractor, not just that has solar experience, but has battery experience, that they've installed many systems in your area over the past few years. And the other distinction is the solar industry has companies that just do sales, and then they have companies that do installations. Make sure the company that actually does the installation, which may be separate from the company that sells you the system, but make sure that company has actually installed all these batteries. And it's not just a sales company that subcontracts out the battery installation to the lowest price installer. Okay, next question. What kind of customer service does your company offer? The answer you're going to get, I guarantee, is, we offer customer service, because it's legally required in most states. But due to the slowdown in the solar industry, many installers have gone out of business, or they just don't answer the phone because they're too busy. And so it's good to check references and look for the installer that's been in business for a long time. Okay, so now let's kind of dive into some of the incentive issues. A question to ask is, there's a lot of incentives out there, but you want to ask a very specific question. What's the real availability of battery or solar incentives to me? Or you ask your installer, do you guarantee that I qualify for the state or local rebates based on my income or fire danger location? You want to ask to see if there's a waiting list for these incentives. You want to ask to see if there's any adjustments to those incentives that are based on your tax rate or your income. So the key thing that I'm trying to warn you about is watch out for incentive scams. There are some installers that are going to claim valuable incentives that are going to cover all the costs. But when you drill down to that, when you're actually filling out the paperwork or you're looking at your taxes, you may find that these incentives are not applicable to where you live. They may have pulled some incentives from another state and they're claiming them for you. They may not be applicable to your income situation. There's more incentives generally for middle and low income people, and the higher income people, at least here in California, they don't get as many of the rebate incentives. The incentives may be expired, or the incentives may have waiting lists. So there's just one thing that you can count on. The only incentive that I know that's available everywhere and for everyone is the 30% tax credit. It used to be the solar tax credit. Now it's the 30% tax credit in the IRA. Now, also note that for some finance systems, if you have a lease or a power purchase agreement, that tax credit incentive is only going to the finance company. So they may tell you a story that there's an incentive, but the finance company is going to keep it and you're not going to get it. So you want to just be very specific about it. Talk to a few different companies, and if you start getting different answers, watch out and drill down into that. Okay. Next question, and this is kind of down to the nuts and bolts. Can I install my battery in my garage or my basement? Sounds like an easy answer. It's like, sure, why not? I can put it anywhere I want. Well, the answer is many cities are following the latest fire and building codes, and they have strict rules about where the batteries can be located. Now, these requirements are evolving. What worked last year may no longer be applicable this year, and some of these restrictions may go away as the battery technology evolves. So, in general, outdoors is okay. Pretty much everybody allows you to put the battery systems out okay, with a couple of constraints that we see happen in California and in some other states. The current codes that are enforced in most of California, not everywhere, but most of California, the batteries can only be installed in garages and basements if you have a automatic heat detection system or automatic sprinklers, and if you put in bollards or curbing to prevent your car from knocking over the battery. It sounds kind of crazy, but these are the rules. So outdoors is always okay. If you want to put it in a basement or a garage, you need some special features. And your installer, if they're experienced, they're going to know what the rules are in your city. Okay. Another kind of question, can I install the batteries on the side of my house? Well, this sounds kind of basic, like, I can put the batteries everywhere. But there are restrictions on where you can put those batteries, and they have to be consistent with the current codes. And they're very tricky. California, in many places, these are the restrictions on batteries. And you have to make sure that your installer makes these measurements. Generally, batteries in California have to be installed 3 feet away from other batteries. They have to be installed 3 feet away from windows and doors that are used to leave the house from a conditioned space. So garage door usually doesn't count, garage window doesn't count, but if it's like a living room or a bathroom window, you have to be 3 feet away from that. It's kind of crazy. 3 feet away from natural gas risers. This is where there's underground gas service goes into the house. They don't want you near that. In some cases, you can't stack the batteries front to back. It sounds really good. You can stack them, but they don't let you. And the side-to-side dimensions are tricky. So let's look at an example. Let's say you wanted to put 2 batteries on the side of the house, and you need about 15 feet of unobstructed wall space. You got one battery that's about 3 feet wide. You got 3 feet between the other battery, and then you've got another 3 feet to the size of the next battery, and then you need some space on either side in case there's a window or a door. It's tricky. So your installer has to make some pretty careful measurements to determine how many batteries will fit. And if they don't, if they say, hey, we're going to sell you 2 batteries, don't worry, there's room. Then the engineer gets out there to measure it, and they find out, gee, we only have room for 1 battery on this side of the house. We have to put the other battery all the way around the other side of the house. And that's expensive to do because there's a lot of wiring that's necessary. So these are things that good installers will measure, and you want to make sure that the installer doesn't lowball the price by ignoring battery spacing issues from windows, doors, gas meters, and property lines. Basically, the only way to really understand exactly where the battery is going to go is for the installer to physically go there with a tape measure and really understand what the rules are. So next question, how will you wire in my existing solar system to the battery, or how are you just going to put in the battery? Now, it's fairly straightforward to wire in a single battery system to your existing electrical panel. They're generally compatible. Once again, we talked about what the power limitations of the battery are and the energy limitations. And so in order to really maximize the usefulness of the system, in almost all cases, we recommend putting in what's called an essential load panel. This is a separate electrical panel that basically just powers the essential things. And there might be another $1,000 or so to wire that in. But if you don't put in an essential load panel, you may find out that when there's a blackout and the battery system tries to power the whole house, but your air conditioner tries to turn on or your pool pumps go on, you're not going to really get along enough duration of the battery. Your battery's going to die kind of early. So once again, your installer has to go there and really understand it. So another way of, kind of talking about that, other question is, will there be significant extra costs to wire my house to provide reliable backup power to my essential loads? And we talked about that, but it could be about $1,000 to put in this essential load panel. That essential load panel is going to pull out the circuit breakers for your fridge, your lights, your internet, your coffee maker. Okay, maybe not the coffee maker. That's essential to me, but not to everybody. But there's a little bit of electrical work. And if that essential load panel is very close to your existing main electrical panel, then it might only be $1,000 to do that. But if you have two electrical panels in your house and your coffee maker is in one and your kitchen is in one and your lights and internet and other things are in another panel, now you got to pull circuits from two different parts of the house, and that's hard to do because you got a house in the way. You got to go under the house in a crawl space, or you got to go up over the attics. So those are going to get more complicated. It could be thousands of dollars or more to rewire the house to move these loads, and that's where you may want to start thinking about some kind of automatic load shedding. All right. Now, that brings up the topic which everybody wants, which is whole home backup. People want to almost every single customer, I want to back up my whole house. If there's a blackout, I don't want my life to be interrupted. In order to do that, just like in general terms, no matter how you slice it, you're going to need a couple of batteries, sometimes even more. And those two batteries are going to have enough power to power the whole house in terms of kilowatts. You start up those large appliances. And those two batteries are also going to have enough energy capacity, even when they're slightly discharged, say in the evening, to keep the appliances running. So the best way to do this, to power the whole house, is to put in a system that has smart breakers in it. I'll talk about what that means in a minute. Or installing some kind of load management panel or load shedding panel or a smart electrical panel. And these are electrical panels that automatically control certain circuits so that if there's a blackout, you'll be okay. So let's kind of talk about the reason for this kind of load shedding that's necessary for whole home backup. You have two problems when you want to try and back up your entire house, whole home backup. The first problem is you have some appliances like your HVAC or your pool pumps or your EV charger or your electric range that are going to draw more amps than your battery can deliver. They're going to draw more power, that they're going to have a surge. And when there's that kind of a surge, let's say the blackout happens, these systems go off for half a second or a second, and they try and turn back on. These big motors are trying to restart, and often the battery system just can't do that startup. Now, the second problem is not a power problem. It's an energy problem. Even when these appliances start up, so you may have enough surge capacity to start these appliances up, but they're drawing so much power that they're going to drain the battery only in a few hours. So even if you have 30 kilowatt hours of battery storage, but you're running your air conditioner and your pool pumps, and that totals 8,000 watts, that 30 kilowatt hours is only going to last you like 2.5 hours. So in both cases, a good solution to this is with your battery backup systems, have some kind of load management or smart breakers or a smart electrical panel or a load shedding device that these large appliances can automatically be controlled, and they can be managed with your phone app for these special panels. And that works out really, really well. Make sure your installer knows how to design, install, and configure and price these features properly. I'll tell you, from an installer standpoint, the easiest thing is to say, hey, you need 3 batteries or 4 batteries. It's expensive. It's hard to site those. Better solution, although more complicated, is to say, we're going to use some kind of smart breakers to be able to manage these things. So you're going to have a better experience. Okay. Next question. And kind of coming up to people who may have a generator or still may have an old generator in the garage, or they may have an automatic generator. Question is, how will you connect my existing solar system or a new solar system to my gas generator? So this is kind of tricky. It sounds like it should work, that you can add a generator to a system, or you can add solar and a battery to an existing generator system. If both the solar and the generator are working at the same time, they kind of conflict. They're both trying to produce power. The generator produces a lot of power because it's got a big motor. The solar produces a variable amount of power depending on how much sun there is. In almost every single case, if they're not designed carefully together with the right kind of automatic switching, they're going to conflict. So you need to know the exact type of generator and the exact specifications, and it's tricky. We kind of have to scratch our heads a little bit when we look at designing a system for somebody that has a generator. It's tricky. Now, here's a gotcha question. I have a generator. Can you install solar with the generator? The reason why it's a gotcha question is many of the home generators that we see They're good generators. They may be from companies like Generac or Kohler or something, good generators. But they were installed without a building permit. And it's cheaper to put things in without a building permit. But the reason why many generators are installed without a building permit is because the generators make a lot of noise. And some cities have noise limits on generators. And basically, if you try and get a building permit, the building department's going to say, hey, what generator is that? Oh, it makes 80 decibels when it's running, and that's too loud. They're not going to give you a permit for it. So what happens is the generator contractors put these systems in without permits. It shouldn't really matter, but that's the reality. And when your battery contractor shows up, your solar and battery contractor shows up to put in a backup power system, they want to get a permit. But if there's an existing unpermitted generator, the city is going to say, hey, wait a minute, inspecting the battery system, did a good job, looks fine, fully to code, but that generator was never permitted and you can't have it. You can either get the permit for that generator or remove the generator. You want to kind of figure these things out before rather than later. And experienced contractors have kind of been through that. In our area, one of the inspectors told us that 90% of the generators that he sees were put in without a permit. And sometimes that happens up in mountainous areas. Okay. Now, another question you have is my existing electric panel? Now we're going to kind of get a little bit away from solar and batteries and talk about the electrical needs of your house. The question is my electrical panel sufficient for the solar system and my future plans for electrification? This is not an easy answer. So we'll talk about what the codes are, the electrical codes are. And these are safety codes. They're basically a good idea, but they're the law. The National Electric Code requires that your maximum inverter output be no more than 20% of your electrical panel size. Now, this is gibberish, but basically what that means is if you have a 100 amp electrical panel, you see these on small houses and old houses and condos, you can usually put in a 3.8 kilowatt or 3800 watt inverter on that 100 amp panel. If you have a 125 amp panel, it's going to be on older homes. That's what was typical in my neighborhood. The biggest inverter that you can put onto that 125 amp panel works with about a 5,000 watt inverter. And if you have a 200 amp panel, which is pretty much standard on most new homes, actually bigger homes are putting in 400 amp panels, that'll usually work with a 7.6 kilowatt inverter. So if you plan to put in solar and electrify a lot with a heat pump, an electric dryer, an induction cooktop, an EV charger, it's kind of what I got at my house, you need to have a 200 amp panel. And I kind of went through the same thing about 5 or 6 years ago. I have a 125 amp panel. And I did all those things. But before I did all those things, I had to make sure I had a bigger electrical panel. And that brings up the little bit of a confusing topic about the difference between an electrical panel, your electric panel, and your electric service. The electric panel contains your main disconnect circuit breaker. It's a big breaker. So if you have a 100 amp panel, it's usually a 100 amp breaker. If you have a 200 amp panel, it's usually a 200 amp breaker, etc. And that main electrical panel may also include circuit breakers to the individual appliances and outlets. What I found is typically in the southern parts of the U.S. and western parts of the U.S., you have what's called a combined electrical panel, main disconnect, and meter main. Whereas a lot of times on the East Coast or northern climates where it's cold, you may have the meter and the main disconnect outside, and then somewhere inside the house, you're going to have your main electrical panel. So these are kind of details to get that figured out. But now talk about the upgrades and why it's kind of tricky. If you need to upgrade your main electrical panel, this is an electrical job. It's not that easy. And here's the steps that we have to go through as a contractor, as an electrician to do this. You need to get permission from the utility. You need to get a building permit from your city. And once that's done, and that's kind of prep work, that's done back in the office, and there's a lot of back and forth going on. Then the electrician and his team is going to go out. They're going to disconnect all the wires to your old panel. They're going to tear out that old panel, and they're going to have to kind of cut into the wall a little bit to do that. They're going to throw out the old panel. They're going to throw out the old circuit breakers. Then they're going to put in a brand new panel. It's one of these gray things or tan things. It's going to have all new circuit breakers that meet some of the latest codes. And once all that's done and they wire all the loads into that new panel, it's going to be really cool. You're not going to have, spider webs and rats' nests and wires twisted. It's going to be safer and cleaner. Once it's all done, then the city has to inspect it to make sure that it was done properly from an electrical standpoint. The utility is then going to come and inspect it to make sure it's okay. And then once it's installed and working, the city's inspecting it, the utilities inspect it, then they're going to give you permission to turn it on. There is some coordination that goes on in this process, and it can drive a typical electrician absolutely crazy. Many solar companies just don't do this, or they try and do it without permits just because it's so complicated. So when we look at the realistic cost for this, with all the hassles going back and forth, there's things that are happening in the office, there's permissions, there's paperwork, you go back and forth with the utility. A lot of contractors charge $5,000 or $10,000 or more, depending on the complexity, depending on the city. And it's not something you can do really quickly. It could take 3 to 6 months or longer. If you think that's bad, wait till you hear what you have to do to upgrade an electrical service. Now, the electrical service is those wires that go to your house. In older neighborhoods, they're above ground. In older neighborhoods like my neighborhood, the wires are underground in conduit. And these electrical service upgrades are also usually done in conjunction with a main panel upgrade. So in my neighborhood, people have a 125 amp main panel. If they want to upgrade to a 200 amp panel, in some cases, the utility is going to say, hey, you've got to change the underground wires. Now, if I had overhead wires, it would be a lot easier. But if it's underground, well, regardless of whether it's underground or above ground, usually what happens for an electrical service upgrade, the city is going to require an engineering application with the utility. So you have to fill out some paperwork, say I want to go from 125 amps to 200 amps, and this is my address. And the utility is going to have their engineers look at it, see if the transformers are big enough, see if there's any other upgrades. Eventually, it may take months. You'll get permission from the utility, and they may say you have to do X, Y, Z in order to accomplish that. Once you've got that figured out, your contractor will then implement that as part of a building permit. You'll get the building permit. Then you've got to dig up your yard to the street. You've got to put an underground conduit. The utilities run wire from the street to your house. They're going to check the piping. There's sometimes 3 inspections. It's just kind of crazy. And then you can go through the process of a panel upgrade, disconnecting all your wires, removing the old panel, putting in the new panel. And then you go through this kind of craziness of the city inspection, the utility inspection. Bottom line, because it's an underground upgrade, it's very time consuming. You're going to have to coordinate with multiple departments at the utility, and these departments don't coordinate with themselves. There's going to be a lot of changes. They're going to change inspections. They're going to change equipment. You're going to have to change drawings. And as a result, it's brain damage. But the typical cost for doing this underground work is $15,000 to $20,000 or $30,000 in 1 to 2 years. I mean, I think it's crazy, but that's kind of the reality. And I really hope that some cities and utilities are going to say, hey, we're going to really make this process easier. But they're busy, and they make a lot of money on this. And for some bizarre reason, they don't want people to do this because they're going to put in solar and buy less power from the utility. So it's really, these underground upgrades, absolute nightmare. Okay, so I'm just kind of warning you about these nightmares. You have 4 options, currently 4 options. If you need to upgrade your electrical panel, and if you need to upgrade your electrical service. And there's some clever new technology options that are going to help. But one option is to upgrade that old 125 amp panel to a new 200 amp panel. And if that requires underground wiring, it's going to be time consuming and very expensive. Another option is if you have a 125 amp service, you can downsize that main breaker from 125 amps to 100 amps. And then you can usually use some technology so that you can put in a bigger inverter, a bigger battery, and other things like that. Now, there's 2 new options, and these are based on some new smart electric panel technologies and also smart inverters. One option is to install the new smart electrical panel that will sense when you get to these limits that you may have 100 to 125 amps, and it's going to prevent you from going over, which is going to prevent that breaker from tripping. And the way it prevents things, it's going to automatically shed load. So if somehow it's a cloudy day, but you got your air conditioning running and your EV charger running and your dryer running, these smart panels are going to say, hey, we're kind of at the 100 amp limit. Let's temporarily turn off the EV charger so we can finish drying our clothes, or so we can finish with the heating or the air conditioning system. The inverters also have what's called a power control system. So the inverters can also prevent too much power being generated by your solar or battery system so that you don't, once again, overload the panel. So basically, not a really easy thing. It's not the kind of thing that, a company calling from, on the phone, never going to your house is going to be able to figure out. It's important to understand what these limitations are when you're planning for a solar and battery system, especially when you're looking at doing an electrical upgrade. All right. In conclusion, we talked about a lot today. And this is one of my longer podcasts. There's a lot to learn about solar and battery systems. You don't need to be an expert on all these things. Heck, I'm not an expert on all of them. I'm an expert on most of them, but we've got really trained people here. But you want to have an expert company that has experience installing and supporting your system. And there are plenty of companies around the country that have been in business for a long time, that have reputations. In order to figure that out, get references from contractors who've been in business for a while because they've figured this thing out and they're not burning the customers with over-promising and under-delivering. So get those references from contractors, and I'm confident that if you find the right company, you might not like what they say, you might not like the price, but you're going to usually get better service that way. All right, that's all the time we have on this week's Energy Show. Thanks to all of our listeners for tuning in. And if you miss any of today's show, you can always go to the Energy Show website at energyshow.biz and listen to the podcasts.